Welcome everyone. Hope everybody had a great spring break. I'm still catching up with messages from everyone. Kata, I'll probably take me a while, maybe should be done by tomorrow to respond to everyone who had some questions. So we did the first exam. We're all done with that. We are about a week behind schedule. We were supposed to do Redux. We did a little bit of it before the break, just to introduce just a little bit. Yeah, no, we're gonna do it in earnest starting today, and obviously for the remainder of the semester. But yeah, all these dates are gonna move a week later, just to give everybody some breathing room and get everything up and going. That's fine. We do have some buffer towards the end that I had a week or two to get going with the project, and if you had any particular issues that we needed to do for the project, we can use that. We can borrow from that time to catch up with this. So I don't foresee any issues catching up with that. So yeah, so really we are here, right? We're going to start covering Redux today, and get you up to speed so you can actually work on assignment A7 Redux. Although I see a lot of you have already gotten started with it, but you know the material, we're actually going to cover it formally today. I saw some of you already getting working on the node assignment A8. Again, please just be careful. We might change a few things at the last minute. Please don't get started on the assignments before we officially cover the material, because it might be that we have to change a few things. For instance, on the A8 assignment, we still are asking you to use, I believe, Heroku, the Heroku servers, and that was written when Heroku was still free, and now they've changed it over to for pay. Although you can get a student license, account where they give you so many minutes or hours that free. So they give you a free server, a free database for so many hours, but you do have to provide your credit card. You have to provide all sorts of things, and they want to make sure that you do have a university email, blah blah blah. And so it's just gotten out of too complicated. So we're moving over to another server solution, which is REST.js. REST.js does have a free tier. You don't even have to provide your credit card. So I am going to make a few changes to A8. It's basically the same, the same content, the same material. It's just that we're going to ask you to, instead of deploying to Heroku, which is no longer free, although again, it is free if you apply as a student, but it's just too complicated now. You're welcome to still use Heroku if you are willing to go through that hassle. But I am going to add instructions so that you can instead choose to use REST.js as an alternative. That you don't need to provide credit card or anything like that. It's totally free. If you keep it under a specific threshold, the entire solution is completely free. But yeah, so that's why I'm hesitant to open up all these assignments and just let you go at it before we cover the material, because a few things are always changing, and we need to tweak a few things, depending on the latest things that we learn about. So anyway, so that's A8, and we're going to cover that next week. Again, all this is going to move 1 week later. We're going to move, all these dates are going to move 1 week later. So I'll update this later tonight. Yeah, so the focus of this week will be Redux. All right. All right. Yeah, so let's talk about Redux. So what is Redux? So what is Redux? So we've talked about state management somewhat already, right? We've introduced the hooks use state, right? That we can create forms that allows us to edit content, right? And now, but that state is only available within a particular component within a particular screen. But we don't know how to share that state, outside of the component, right? We could share the state of a component maybe with its child components, right? Because we could pass data down to the child. We can even pass functions, right, down to the child so that the child can talk back to the parent, right? So they can communicate. You have a component that contains other components, right? And the parent component can pass data or objects through the attributes, right, out to the child components. And then the child component can then use that data to render whatever, right? And you can also pass functions, and the functions in the child can then call those functions back to the parent. So it wants to update the state within the component. So components can talk to one another from the parent down to the child. But then there's no easy way to then allow data that lives in that component to be available elsewhere in the application, right? The only way we could do that perhaps is to, if we want the data that lives in a component to be available elsewhere, is that we would just need to define that data at a higher context, right? And then that trickle down that data down to the components that need it, right? So that problem, that's exactly what Redux is designed to address, right? How do we make data that is relevant within a particular component? How can that data then be shared across multiple components, right? So there's a differentiation between data that is component based, right, or which is local to the component, and then data that is that is relevant across an entire application, right? So we want to make that distinction: data that is component data or state data that is for a particular component, and there's also state data that is application-wide, right? Application-wide state. Okay? So how do we go between these two worlds, right? And that's what Redux is designed to address, right? So I'm gonna show you what I mean by having data within a component and then sharing it outside, and what are the challenges, right? And how Redux can be used to fix those challenges. Okay. All right. So let's see. Let's just have a routes and make this bigger so you can see what I'm doing. And do a route path. And for now, we'll just have a element just says hello. Okay. Just start from really scratch. Welcome. All right. Okay. And let's see. And we don't even have link yet. And let's do an npm start. Okay, let me put this side by side so that we can work side by side. You can follow along what I'm doing. Okay, so we just have a welcome, right? Just says welcome. There's nothing in this application. So let me just show you. So for instance, imagine we were logging into an application, right? And certainly the information about whether who's logged in is certainly of interest across multiple screens, right? Like for instance, the login screen certainly wants to know whether you're logged in or not. When you're registering, certainly you want to know whether you're already logged in, but you don't want to allow somebody to register if they are already logged in, for instance. The profile screen also want to know, whose profile am I looking at right now? So that if I'm editing that profile, I know that I want to know, that you're logged in and you know who you are and whatnot. if I go to other screens, if I go to the checkout screen or the shopping cart screen, it's relevant to know across multiple screens who's currently logged in. Yes. So uh, I want to show you an example, right, where you're editing your profile, say, but then we don't quite know how we could share the information while we're editing our profile. How that data could be shared across multiple screens, right? So I want to first show you that challenge, right, that problem. Okay, so let's create a screen, and let's call it new file. I'll call it the profile screen. So profile screen. Okay. And the profile screen might look something like this, right? We might have function, profile screen, and this returns for now and maybe profile screen. There we go. Export profile screen. Okay. And then in an app, we can maybe have a route for the profile screen. There we go. And we'll need to maybe import our profile screen. Okay. And it's mapped to profile. All right. So we'll need to, we need to navigate to the profile screen. Are we using it here? Oh, okay, no, this is the component here would be profile screen. Up here, we'll create a couple links. Link, yeah, and then profile. There we go. All right. This tool is really cool. I'm using GitHub Copilot, and it's it's an artificial intelligence that kind of reads your code and guesses at what it is that you're going to type next. It's very good. It's scary good. All right, so I can click on profile and we should be able to navigate to profile. So home, I can toggle between the two. Everybody good? Nothing new here, nothing new whatsoever. So in the profile screen, we might have objects that represents a user, right? So that we can edit that profile, right? We can say, const, I'll want to call it profile, set profile. And the, not quite, this is use state. No, use state. Yeah. Hello. And maybe we want to initialize first name, John, last name Doe, email jdoe @gmail.com. Okay. Yeah, phone, whatever. 1 Main Street, sure. And we'll need to close this like that. And this needs to be a square bracket, not a curly bracket. And we'll need to import this. React use state. Yeah. Okay, there we go. So yeah, so how would we edit this, right? We would have a couple of input fields, right, that would allow us to edit this, right? So we would have maybe, let's see, we would have an input field or maybe a label that says first name, right? And then it has an input field input that displays the first name. Very good. It has a label for the last name, an input for the last name, very good. An email, input for the email, phone, there we go, perfect. Wow, this AI is really, really good. And maybe we can break it out, right? We could put some BRs here. So we can break it out a little bit. There we go. Let's see what else. There we go. Right. So we can edit that. Certainly we can make this a little prettier, right? But I'm not gonna waste your time making this prettier. Certainly you can add some bootstrap, right, and whatnot. But the point that I'm trying to get across is that the state variable here. This is the state variable. Is right now lives inside of this screen, right? And it cannot be accessed anywhere outside of the screen, right? So, for instance, if I want to use it in the login screen or the registration screen, or want to use it in the home screen or anywhere else, right? There's no way for me to share this information with anyone else, right? I can modify it here. So, for instance, the profile, I could say, on change. Yeah, there we go. Our AI is really good. Says that if I want to edit, if I change the first name, right, it updates the profile with the copy of the old profile, and the first name copies it from the target. Very good. Same thing with each one of these. I could do an on change for all these. On change. Yeah, it's filling it up for me. Very good. And it closes it, I think, maybe. Oh, missed out the parentheses. I think it missed out this parentheses. So now I can change this, right? I can say Jonathan, right? So I can edit this. I can't edit these. Can't edit these because I haven't done the update. Yes. So yeah, so we know this already, right? This is something that we already know how to do, calling the setters, right, that are declared in using our use state. But there's no way for us to share this anyway outside of this screen. So what do we do? What could we do? Well, we could define this. We could define this information maybe here in the app. Define it somewhere here, right, and then share it down to the screens that want to use it, right? We could pass it in, but then this the information about all the logic about updating the profile, all these functions would have to be passed into to each one of the screens, and then the screens have to talk back to the app. It would be a mess. It would be a huge mess. Right? So we're not going to do that. We're not going to move the information about the profile here in app, right, and then share it down to the components that want to use it. Instead, we're going to use a different technique, right? And the technique is is implemented by the library Redux, right? And what the library Redux does is that it allows you to take state variable, right, variables that are declared in a local component, and instead declare it in a global context, right? That can then be accessed or selected from the components that are interested in that information, right? They can pull that information from this global context, right? So let me show you. So the way it works is that you declare. Okay, so we're going to create a directory. We're going to call it Redux. Let's say new folder, Redux. Redux. And in here, we're going to create a file called the user reducer, meaning this is going to maintain the state of the user, right? And so in this user reducer, and we'll see why it's called like that in a minute. Here, what we're going to do is that we're going to move anything that we want to make globally available, right? That doesn't belong to any one component, right? We're going to make it globally available in this reducer, and all the logic that that we need to maintain this this state, right? It's also going to be moved here, right? So we're going to decouple, right? We're going to decouple the data and the management of that data, right? And how it changes over time. That's going to live in one place, and then the components, right? These screens are just going to consume the data from the reducer, right? So they're no longer going to be responsible for maintaining the state, right? They are only responsible for reading from this global state, right? And then sending any messages back to the reducer saying if things have changed over time, right? So the state is no longer going to be available. So and then we need to be able to maybe synchronize, right, this local state, right, this profile state that lives in the profile screen, and synchronize it with the global application state. Okay. All right. Okay. So what we're going to do is that in this user reducer, we're going to declare first the state that we want to manage. We're going to create first the initial state, so const initial state, and yes, it is going to be the user. Very good. And we're just going to copy this information right here. We're going to copy this information. Copy. Oops. And we're going to put it right there. Very good. I'll close it, and there it is. Okay. And then, yes, what we're going to do is that we're going to create what is called a slice. Right? In the Redux world, there can be many pieces of information, many slices of information that we're interested in handling. Right? We want to handle maybe who the current user is logged in. We want to handle your shopping cart. We want to handle the orders, right? We're going to handle, our preferences. All these information would have their own independent slice of data, and together, all these slices make up the entire pie of the data, right? And then slices allows us to treat each piece of information independently from the other slices. Okay, and the way you create these slices is with the function create slice. Right? So yeah, there's slice. Each slice has to have a unique name. In our case, right, our AI is choosing user. That's perfect. That's exactly what I was going to do. It also takes the initial state, right? What is the initial data, at the beginning, but that data might change over time, right? As we change our name, our email, our phone, our address, right? We can tell the slice, right, to modify that data, right? So typically, the attributes here, right? These are required attributes like the name. So when you create a slice, you need to provide a name. You need to provide an attribute or property that call initial state. So notice that this is just initial state, comma, right? This is the same as doing this. Initial state colon initial state, which is the attribute called initial state, and the value is this variable over here, this constant. Right? In JavaScript, JavaScript is a great language for lazy developers. When the property name, right, is the same symbol as the variable or data or value that is being set to, you can abbreviate it, right, but just using the initial state, right, which is great. Okay. And then you also need another attribute in the slice, right, called the reducer or reducers. Now these functions would be responsible for updating or maintaining the changes in that state, right? So for instance, if we want to handle being able to update the first name, last name, or whatnot, right? here's where you put functions that are responsible for computing the next state, right, of having modified the user. Right now, we don't have anything. We're not modifying anything just yet, so I'm just going to leave it empty. And we'll close that. And then we are going to export the slices reducer. There we go. Perfect. Okay. All right. Excellent. So so these are reducers. Now we can have multiple reducers, right? Again, one that handles user information, one handles shopping cart, another handles orders or products, right? So each piece of information would have its own reducer. So right now we only have one reducer here, which is called the user reducer, but we can have tons of other reducers. Okay, so each slice is responsible for that, for each data. Now we need to import this function, right? So let's import this. We'll say import. Let's see. Yep, our AI knows how to import that. Very good. What else? Okay, so once you have all these reducers, right, each one with its own slice, they need to be combined into one single data store, right? Like one big bucket that combines all these different slices into one big pie, data pie, right? Called the store, the data store. So let's create that. Let's create the store. We'll say new file, let's say store. So this store, what it's going to do is it's going to configure this store in terms of all those slices, all those reducers. Right. So let's create it. We'll say const store, and we're going to configure the store. And the function configure store is part of the Redux library, and it takes it takes one property, and called the reducer property, where you list all the reducers, right, that handle the different data slices, right, to be combined into one big data store. Okay, here our AI is taking, we want the user reducer, so the user reducer. And right now we only have just that one reducer. And we're going to export it. Perfect. But here you would have, we would need to import this user reducer, which is in the same folder. So we'll say import user reducer. Perfect. And so so the reducer is a map. Notice that it is a map, right? That has name value pairs. So the user reducer is defined in the reducer file, which is responsible for providing or calculating the current state of that slice of data slice. Right now, the data that is generating currently is this initial state. Right. So what this is, user reducer, it's a function. Notice that it's a function. Right. It generates a function so this evaluates, this user reducer is the first time around, it evaluates to this initial state, right? This initial state, and we can access it or make it available to the rest of the world through this namespace called user. And we're going to select that slice of data through this namespace called the user, right? And you can use any name, right? You can choose to be whatever you want it to be. Right now, we're using user everywhere. Okay. All right. So how do we make this available to the world, right? So how do we do that? So what we do is that in the app.js, right, at the top level of your application, right, what we do is that we're going to wrap the whole thing. I'm going to wrap our entire application with a provider. Okay, and this provider is going to be our global provider of the data, right? And so we need to tell it where to get this data, and then each component, right? For instance, a profile screen. can pull the data that it wants from the store. Okay? So let's see. So the provider needs to have a store. So what store is the store that we just created 2 minutes ago? Let's create it here. Let's import it. We'll do import the store. Very good. Actually, no, it's not there, right? Where is it? It's actually under Redux store, I think, right? Is that where it is? I forget. Yeah, that's where it is. And then the store, we can set it here, store. Okay, we're back in business. All right, everybody still good? I know this is a little bit too much right now, right? We're gonna repeat this over and over. We're gonna do tons of examples, one after another, right? And until until you understand it. But really, the understanding will come when you try it yourself, right? Once you practice it yourself a couple of times, then it will start making sense, right? Once you do it once and twice and 3 times and whatnot, right, it'll start becoming second nature. And so now the store is made available at the root of the application, and then any component now, the profile screen or any screen, right, can pull that data from the store. Right. So let's go back to the profile screen. So instead of using this data here, right, this might, yeah, it broke. It broke because we're not providing any data. Let's grab that data from the reducer. So the store has the data, right? We're going to grab it from there. So how do we do that? We're going to grab the user, say, grab the user from the selector. So use selector is what is a function of the Redux library. We'll need to import it. There we go, from Redux. So for use selector from React Redux, and it's a function that will be passed. Right, that at the beginning of this app is providing the store. It's available globally, and from that store you're going to be passed the current state, which includes this. This includes everything that's being added to the store. Right now, the store only contains this the data that is coming from this reducer, and it's being attached to the namespace user, and we're extracting it here. We grab so this whole object is what the state is, right? And then we can grab from the user namespace, which is this one. We're grabbing that, which is whatever is being contained or generated by this reducer. What is being generated by this reducer? This object, right? This object right here. And what we're doing is that we are picking out that user object, right, from that namespace. So now this user is equal to this right here, to whatever user is, which is this, right? So we can use that now. We can use that as the initialization of the local state, right? And now we're back in business, right? So now we're back in business. See that? Okay. And so basically, what we've done is we've moved the data outside of this component. It is being handled by a different function, but then we need to pull it from there so that we can initialize our local state. So we're copying from the global state whatever we want to grab from there, right? And then to initialize our local state, right? So if I can change that, I can go back to the reducer. I can change this to being something else, Alice Wonderland or whatever, right? If I save that and I refresh this, notice that this is Alice Wonderland, right? So now the state is being entirely manipulated or initialized or controlled by this reducer, right? It's no longer being handled by the profile screen. The profile screen is just reading that data. Make sense? And so now because now this data lives outside of this screen, I can share this data with any other component, right? Any other screen can render information. For instance, in this app, right? Instead of this welcome, let's create a home screen. So say I had another screen here, and I'll call it home screen. So home screen.js, and I had React and this will be a home screen. It will be maybe h1 home, and say that I can navigate here. My root here is home. Let's say home screen. Okay. So if I go to home, here's my home, right? Which says home. So the home could also pull information about that user. Same thing. We could say const user use selector. Yeah, the same exact selector as before, state user. We'll need to import the selector. There we go. And now we have the user, and then we can say h2 welcome. There we go. Our AI is really good. It says welcome user, first name, last name, right? So welcome Alice Wonderland, right? Because this information is available now globally, and each component or each screen can pull that information from this global context. That makes sense? So it no longer belongs to any one screen, right? It's a globally available data across all screens. Make sense? All right. Okay. All right. So now we've talked about being able to pull data from this global state. What about being able to update this data? We know that we can change the data here in the profile by saying set profile, right? So, but set profile would be editing what? It would be editing our local state, right? So this set profile, when I say Alice, that changes to Alicia, right? And notice if I go home, this still says Alice, right? Where if I change this, right? Notice that home still says that it's Alice, right? It is changing locally here, right? Because notice that if I render it anywhere else, if I say render profile that first name, there it is, right? So if I change it locally here, whatever I change, notice that it is indeed changing locally in this screen. But if I go anywhere else, I don't see it. I never see it. So how could we do that? So somehow we need to make these changes, right? Whatever whatever screen is changing it, somehow it needs to make sure that the global state changes. Okay, this global state. So how do we do that? And that's where reducers come in, right? Reducers are going to allow us to make changes or compute the next state, right? So let's do it. So let's create here a function that allows us to update the user, right? Our AI is very, very good. It says, and yep, that's exactly what I was going to write. So the function is called update user. Now, all reducers are written the same way, right? They take the name of a function and then assigned to a function declaration. Now, these functions are always they always take these two arguments, right? They take the current state, whatever the current state is. In this case, it would be the initial state, this right here. So what reducers are, they are a finite state machine, right? They're like a finite state machine that allow you to go from one state to some other state based on an event, right? That causes you to transition from one state to the other, okay? And so in this case, the event is update user, right? And so we need to tell, right? We need to tell our state machine right? That if you are in this particular state, if this event happens, then you need to go to some other state. So our function takes the current state, where am I? This is what happened, right? And we can compute what the next state is. We can say, well, the next state is that the user in that state, right, will change its value. Okay, so what value? So what value should user take? Right. So the state machine has the event, it has the current state, but it also has arguments. Right. So the event, when the event occurs, we can pass parameters about that event. What happened? Right. Oh, somebody deleted this or updated this or added something or right. And we can pass parameters, right, that can configure how that computation for the next state should be. So in this case, what we're going to do is that we're going to pass, because the event is update user, what we're going to pass is what the new user should be, right? If I edited a user, a first name, then the next state should have the first name of that next state should be whatever updates of the first name was, or the phone number or the email or whatever, right? So any changes should be updated. So what we're going to do is that so the action represents the parameter of what happened, of the event, right? Again, the names here don't have to be state and action. Those are the most commonly used names for these parameters, but they could be whatever. They could be X and Y. Now, action, by definition, needs to contain a property called payload. Payload is the actual data that we are passing or as a parameter across, right, to the reducer. We're going to pass data. For instance, it would be the new user, right, that contains the new first name or the new email or the new phone or the new address or whatever, right? And what we're going to do is that we're going to just override, we're going to rewrite the user variable to contain whatever the payload is. So that the payload will contain a new email, and that means that the new user, right, will contain that new email. Make sense? All right. So we need to be able to call this update user from the profile, right? Whenever we actually update this profile, right? We know how to change it locally, but we need to let the global state know that it should update its state with whatever we have here, our local state, right? So this allows you to copy the state from the global state into our local state. We need to go backwards, right? We need to be able to copy from our local state and copy it over again into the global state, right? So that's a challenge here. How do we synchronize, right, the local state in one screen, right, from the global application state and vice versa? How do we update the global state from our local state if we're going to update something, right? So first of all, we need to export this function so that it's actually available outside of this reducer, right? So let's see. We're going to export the actions user. Perfect. So we're going to export this function. There it is. Export so it's available to the rest of the world. Very good. Okay, so how do we call this function update user and pass it a new data? Well, what we're gonna do is that we're gonna take whatever updates we are making to our local profile. We want to do the inverse of this. So this allows us to read data from the global state. We want to dispatch. We're going to throw data at right here this payload so that we can update this user state. So how do we do that? So how about we'll create here a save button. Let's create here a save button. And save button. Call it save. There's our save button. And maybe make it a little prettier. Maybe class, button, primary. And we're going to float at the end. There it is. Okay. So when we click on it, let's call here a handle save button. Okay, there it is. All right. So what is it that we want to do? We're going to call this function, and we say on click. We call handle save button. All right, and maybe this will be an alert for now. So we click on save. All right, there we go. Save button click. Okay, so what we're going to do? So what we want to do is send whatever updates we make to the local profile. We want to send it over and update globally, right? Because right now, any changes that we're making, yes, they're changing locally, but no one else is seeing that. So we're going to click the save, and so that we can save that globally, and then everybody can see it, including my home screen. Right. So how do we do that? All right. So what we do is we're going to first grab a dispatch, right, using the function use dispatch. So the dispatcher, this dispatcher is a function that allows us to send over data to the reducer. It allows us to invoke this function and send the data across. We'll also need that function. We'll need this this update user, right? So let's grab that. So an import update user, very good, from the Redux actions user actions, very good. Is that it? User actions. No, I don't think that's where it was. Redux user reducer. There we go. Yeah, that's where it's defined. And what we're going to do is that instead of doing this alert, right, we're going to dispatch. There we go. Yes. We're going to dispatch. We're going to call the update user, and we're going to pass the new profile. Right? Whatever updates we made, right? When we save it, we click on save, we're going to dispatch to the update user function the new profile. And this function and this value here in the profile is going to be the payload. See that? So if I made changes to the first name, last name, email, whatever, that is all in my profile, right? And that's going to be in the payload. So it's going to grab it from the payload and it's going to update our user, our global state user. Okay. So now if I say, Alicia, and then save, right? If I go home, notice that that indeed has changed everywhere, right? Any other component that is reading from the global state is now aware of those changes because it's changed for everyone. If I go back to the profile, that change has been made permanent, right? In the application at the application level, right? Everybody sees this. Obviously, if I refresh the screen, all my changes go away, right? And the initial state is reset, right, to be whatever it was before. Everybody good? Everybody still with me? Okay. All right, let me do one, something a little easier, a little simpler. Just to step back a little bit, right? This maybe might have been a little bit too ambitious, but let's change. Let's create another screen, right? And we'll call it a counter screen. So just a really simple counter, just counts one, right? Up 1, 2, 3, or down. Okay. So this might be something like a function, counter screen. And for now, return div and counter screen. Yeah. Export. And then our app here, we're going to create a route for this. Let's see if it picks it up. No, it doesn't. Let me import that here. The counter screen, very good. And here, let's create our route counter, perfect. Oops. Hey, there we go. Yeah, and we'll create a link for it. Yeah, perfect. Excellent. So you can navigate to the counter. There it is, counter screen. So in their counter screen, we have a counter. Say we have a const, and this is counter with initial value 0. We'll have to import this. There we go, perfect. And we initialize the counter to be 0. So we have a counter is 0. Very good. Now, if we want to update it, we could have a button that on click sets the counter +1, right? And maybe we have another button that allows us to set the counter to -1, right? And so we can increase or decrease. But nobody has access to this counter, right? Correct? So how can we update this? How can we make this available, this wonderful counter everywhere else, maybe in the profile, in the home, so that everybody could see the wonderful value of the current counter? So, so what do we do? We could use the same technique that we just talked about, right? We could create a reducer, and we'll call it the counter reducer. All right. We can initialize it. We can declare an initial state where the count is 0. Perfect. And that's it. We don't want to make it more too complicated. Then we create a slice, the counter slice. Perfect. The name is counter. The initial state. Perfect. Reducers. We don't have any reducers just yet. And then we want to export it. Perfect. Then we're going to update our store. Remember, our store combines all the different reducers, all the different slices, right, into one store so that everybody can grab the pieces that they want. Okay. So let's go to our store. So in our store, we're going to declare our new reducer. So it's a counter. The counter reducer, perfect. We need to import it, right? We need to import it. Perfect. There we go. Oops. Create slice. Oh, yeah, we forgot to import the create slice here, right? Import. Okay, excellent. Yeah, so okay, so now we have both the user information and now we have this counter so that everybody can grab the values from the reducer. We don't need to update anything here, right? The provider is just providing that store to everybody, right? Now the store not only does include the profile information, right, the current user, but also this counter, okay? So now the counter screen, what we're gonna do is instead of initializing this from 0, we're going to select the global state, right? We're gonna say const. Now what's in there is the count from the state counter. Perfect. Yes, counter. Right. And we'll need to import this guy, right? Import the selector. And now we can initialize this count here, right, as 0. Right. Notice that I can initialize it to anything. If I go back to my reducer, I'm going to initialize it to 1, 2, 3. And if I refresh, notice that it's 1, 2, 3. So here we are grabbing the count from the global state. Now, why count? Notice that this is counter. Counter is the namespace that we gave it in the store. That's the name. So this counter is this counter here. Now this count, we're extracting, we're deconstructing what's in here is whatever the reducer returns. Is this initial state which contains the count, right? This object is what we get here, right? So what comes back after the state counter? This whole object, which contains a count. And that's why we are deconstructing that count. And we're using it to initialize our local state. Everybody good? All right. Now, this value 1, 2, 3 can be seen everywhere. In my profile, I can see the count, right? If I go back to my profile, not that is a very interesting thing to see in my profile, but just to illustrate the idea is that right now count is available everywhere, right? So I can, in my down below here, I can say the count is H2 counter count. There it is, 1, 2, 3, right? Same thing, it's available in home, everywhere, right? You get the idea. Right? I can grab the information, count from counter, and H3. There we go. Everybody good? It's available everywhere now. Okay, now if I update it, I have the same issue, right? If I go to profile, I don't see those changes, right? I'm changing the local copy, but I don't see it everywhere else. Now, we could do something like this. We could do in the counter screen, in the counter reducer, right? We could create a kind of like an update counter. Yes, that's where I was going to go, but I can say, update count, yeah. We're going to initialize, we're going to update the current state of the count, right, with whatever we pass in the payload. So the payload will have the new value, which will be copied from the local state, right, whatever I made here. And so we'll create a save button, right? So let's do that. We need to export this. Need to export the update count, very good. And then from our screen, we could have a save button. So let's create a little save button. Button float n, very good. There's our save button. And what we're gonna do is we're gonna grab the dispatcher. Oops, no. Const dispatch, use dispatch. We'll need to import it from here. Use dispatch, very good. And then we can handle, handle save count. Counter, yeah. It's going to dispatch the update counter with the new count. Update count. Oh, we need to import the update count, right? That we exported. Yep, there it is. And we're going to call that function when we invoke the onClick. Right, handle the save. So now, right, if I make changes and I save, right, if I go to profile, I have that update everywhere else. You see that? Everybody good? Everybody good with that? Okay. Now, there is an optional way of doing this. Right? There is a more direct way. So this is the preferred way. This is a preferred way, right? Where where you make changes locally, right? And those changes are not yet made available until you save, right? Notice that if I go everywhere else, I still have the old value, right? And when I go back, I lose the changes. And so those changes, those local changes, are not made available until I deliberately save it, right? And then they're made available everywhere else in the application. So this is the preferred way. But oftentimes you want to be more granular, right? This is kind of like, maybe you have like a long form, right, that you need to fill out, and not until you hit save, then you grab all that, right, and you make it like a wholesale save, right? For instance, you don't want to, and most of the times you don't really care about each single stroke, right? As you're typing, right, it might not interest you to make the changes, for every single stroke, right? That you are updating every single stroke, the entire state, right? Instead, you want to leave the local state, right? Handle all those keystrokes. Once you're done, like we do in the profile, we are making local changes, but not every keystroke is telling the global state that, hey, you changed something, right? We are collecting all those changes, and then we're doing a wholesale change. Yes, when we do this, this saving here. But there are cases where we do want to be granular, and for every single keystroke or every single button press, we do want to update the global state. Yes. So how do we do that? So without the save, right? So for instance, whenever we click on every single state, every single link, every single button, right? So we want to do a little more granular. So let's go back to our counter reducer, and let's implement an increment. And we want to, and what we could do, right? What we could do is instead of setting the counter local here, right? We could, instead of doing a save counter, we could dispatch right here immediately instead of setting the local counter. So let me show you. We could do it locally here. Const update counter, right? And we're going to pass new count, right? And so yes, it's going to update the new count locally, but it's also going to dispatch the new count. See that? We're going to give it the new count right away. And so instead of doing the set counter here, right, we're putting it together, updating the local state with the new count, and we're going to update the global state, right? And here, instead of doing this set counter, we're going to do update count, right? And so we update it with the old count plus 1 or minus 1. We have the new count, and then we copy locally, and we are notifying the global state right away, immediately, without waiting for you to click on the save. See that? So now, if I make these changes, I am updating the global state for every single click without having to click on the save. So if I go back to profile, notice that it is changed everywhere. See that home and 11, whatnot. Now, this is a choice, right? It's a personal choice of your design on whether what you are changing, if the state that you are changing is worth notifying and updating the global state for every single keystroke, for every single button click, right, or not. That's entirely up to you. It's an entirely design decision. Make sense? Now again, the general best practice is to do a wholesale change, right? Where you do all your local changes locally, right? With your own local state variables, right? And then once you're ready, right, you save, and then that you copy the local state to the global state to make it available everywhere else. But again, there might be edge cases where you want to be more granular. Everybody good? All right, with that said, I am going to present yet another example. This one's going to be a little more involved. It's in the same thing that we've already worked on before. We're going to implement a to-do list, and so we're going to re-implement what we implemented, a couple weeks ago. We did implement a to-do list for the React homework. You were asked to do a to-do list, but it was using all local state. So now we're going to rework it. We're going to redo it again, but this time we're going to be using the Redux application level state. Okay, so that you can contrast, right, and look at how is it implemented using only local state, and how it would be implemented using global state. Okay, all right. So yes, let's do that. Let's see. So let's first we'll need a screen for a to-dos. So we'll create it. We'll say new file. This will be a to-dos screen. Okay. All right. And so we'll have a function to-dos screen. Oh wow. Yeah, no, we don't have that yet. And so for now, we'll just have oh wow, look at that. This is wanted to implement a to-do all by itself, but yeah, no, we're not doing this. This was what we worked on last week or the week before we left the break on how to implement a to-dos using local state, right? But in this case, we want to do is use a reducer instead, right? So let's for now we're just going to do a return div to-dos. I'm going to export. And then in our app, we're going to create a route for the to-dos. Let's import the to-dos. Okay, and here we're going to do a route for to-dos. Yeah, and we'll do a new link for the to-dos. Perfect. And we'll need there we go. So we go to to-dos. It's just listing to-dos. Everybody good? All right. So again, we have to make a decision on how do we want to do this, right? Do we want to have this screen use a local state, right, that does all the changes here, but those changes are not made available until we save, right? And then they're available everywhere else? Or do we want to be granular and every time I say I add a new to-do, there's no need for me to save to then see everywhere else, right? So it depends. How do we want to handle this? Do we want to be very granular? Do we want to only work locally, right? And then when we save, then we copy that state to the global state. I'm going to do a little combination of both, but I'll try to be as granular as possible, right? So that the to-dos are always available, right, for anyone to see without me having to click on a save button. Okay. All right. So and again, that's a personal design decision, right? So yeah. So let's first create a reducer, right? That was going to hold an initial set of to-dos, right? So let's see. So we'll create a to-dos reducer. So a Redux, a new file. So this would be a to-dos reducer. And so we have an initial state of to-dos. All right, very good. It's an array of to-dos. Yeah, text, learn, react, perfect, completed. IDs, very nice. Build something fun. Yeah, our AI is killing it. So let's see what it did here. Let's so it created a couple of to-dos with some completed flag, whether we completed that task or not. Also colors, I don't really care for these colors. Yeah, build, learn, react, learn, build something fun. Perfect. Okay. And has IDs. Perfect. Excellent. So we'll need to create a slicer. A slice. There we go. We have a build a slice. And the name is to do. Perfect. Initial state. The reducers. For now, we're not going to have any reducers. But yeah, I mean, obviously, eventually we will, and we'll have to export this. Perfect. We'll need to import the create slice. Import create slice. Perfect. Okay. Now that we have the reducer, right now it's just the data, right? It's just an array of to-dos. We are going to then add this new reducer to the store. Right? So we want to say to-dos, the to-dos reducer, perfect. And we're going to import that. Import, excellent. So now the to-dos are available in this namespace to-dos. So from our screen, we can import them now, right? We can say, we're going to grab and say const to-dos from the state, perfect, excellent. And we'll need to import the selector. So import React, and we'll need to import the use selector. And now we can just iterate over it, right? We can just say UL to do, yeah, it does the key, everything, to do title. There we go. There's our, oops, we broke something. To-dos, what's going on? To-dos, blah, blah, blah. Use selector to do. Oh no, wait, no. This is supposed to be in here, right? Like that. There we go. Okay, these are not titles. I think it's just text. No, the text. Perfect. And obviously, we can style this and make it prettier, right? Class name. This would be a list group, right? And these would be class name. This would be a list group item, like that, something like that. Okay, all right. Everybody good? All right, perfect. Yeah, so we know how to pull data, and we can then iterate over that data and just render it. We want to be able to manipulate this, right? Maybe able to create new to-dos, able to delete to-dos, maybe update existing to-dos and edit them, right? That's what we built a couple of weeks ago, right? And that's what you did, I believe, for the React.js assignment, right? You were asked to implement some kind of a to-do, and so let's rebuild that by using Redux, right? So let's see what can we do here. Let's get started. Maybe being able to delete a to-do. All right, we'll add a delete button. Maybe we'll add a button with an X. Okay, there's our X, right? That for delete. Right? Our AI is reading our minds here. So X is for deleting, and so for deleting, we need to implement that, the new state, we need to implement that in the reducer, right? So let's implement a delete to-do reducer. Right, so we'll implement first delete to-do. Let's see our AI. Yeah, perfect. It's iterating over the to-dos. It's filtering the to-dos IDs, right? And we are going to be passing, presumably, we are passing the payload, the ID. So this is what it says, right? That we are passing the ID of the to-do that we want to remove, basically, right? Actually, what I want, yeah, I mean, that's good. That means that we're passing the ID. That means that here from the screen, when we click on this button, we need to dispatch the ID of the to-do that we don't want here anymore, right? So let's do that. Let's grab the dispatch. So let's add the use dispatch. We'll grab the dispatch and we're going to handle the delete. We're going to say we want to use this new delete to do. We'll need to export this, right? Export the delete, very good. And in here, this button, we can dispatch it right here. We can say on click, we are going to dispatch the delete to do, and we're going to pass the to do ID, right? Oops. Do we have the delete to do? Yes. Is that what it's called? Delete to do? Yeah, and we exported it. On click. What did we break? Do we have way too many parentheses here? Looks like I have way too many parentheses. Let's see, this one closes this. This is this. Like that. There we go. Yeah. So we're passing to a delete to do the ID of the to do that we're going to remove. Let's see if this works. Yeah, it works perfectly. Excellent. So refresh. Everybody good? Obviously, we could have put this instead of a handler. We could have put here an on-click, delete button handler, which just dispatches the delete to do ID. Yes, we could have totally done that instead. How about creating a new to-do object, right? Which basically would be appending a new to-do object, right, in the to the current array. So, for instance, in the reducer, we can implement an add to do. So add to do. Let's see our AI state action. It's going to take the array of the to do, is going to push whatever object we pass in as a payload. All right, and we'll need to export this as well. So add to do. So here what we can do is create a new line item where we have we can have a button that adds a new to do, right? So let's create a line item here where we have a button that allows you to add. There's a plus button. Yeah, very good. There's a plus button. And maybe an input field below it, right, that allows it to type the description, right, or the text for that to do, right? And when we click on the button, you can say on click. We're going to call the add to do. There we go. Yeah. But it's expecting an object that represents the new to do, right? And so we can create an object right here. It's suggesting that the ID should be whatever the length of the to do is plus 1. Sure, that could work. Although that doesn't guarantee that the IDs of the to-dos are unique, right? So instead, what we're going to do is we're going to calculate a date, a new date, and we'll do a get time. Get time will grab the number of milliseconds. All right. Oh, we never imported add to do, so let's import it here. Add to do. What else can we pass? Maybe we can pass the text. The text is new to do, and completed false. Perfect. All right, so let's see if this works. Maybe the initial value of the input could be new to do. So when we click on plus, let's see, there we go. See that new to do is being added down below, right? And we can still delete. Each new to do is being removed correctly, right? Because it has a unique identifier, and we can add new to dos. Everybody good? Now, presumably, because we are updating the global state right away, we don't have like a save. Right? Ideally, we should be able to go home and see the update immediately, right? Let's see if that's true. All right, so if we go to home, where's home screen? We should be able to grab the to-dos, const to-dos, and down here, right, H3 to-dos, it should be able to render them. There they are. See that new to-do. If I refresh, there's a 3. But if I go to to-dos and I add a few, if I go home, notice that they are indeed available in the home screen without me having to set save, right? Because I am being very granular about my updates, right? I am immediately calling a dispatch, immediately when I click on the plus, immediately when I click on the X, right? I am dispatching right away, updating the global state. So everywhere, right? If I go to profile or home, everywhere, I can see the immediate state changes all throughout the application. Make sense? So yeah, let's keep playing with this. So instead of this being hard coded, right? Maybe I can I want to be able to type in the actual text, right, for my new to do. Now here's where the question might be, well, I know to be able to change the value of an input field, I need a local state, right? And as I am changing it, I need to update the local state, right? So that's where a combination of local state and a combination of global state come in, right? So to capture this this text, right? To capture this text, I'm going to use a local state, right? So here, I'm going to create a new to do, local state, new to do, and then a set new to do, and the state is going to be an object with the ID, text, sure, and completed false, right? We need a use state. We need to import this use state. So use state, and then this input field, right? The value is going to be new to do dot text, right? And as I type, I should be able to update it. So on change, it should allow me to set the new to do to be the old to do, and the text is going to be the value from that from that event. And so now I should be able to type whatever I want, right? And then when I click on plus, now the plus is still not doing anything. It's always new to do. But now, instead of me sending this add to do, the text, all this, right, could be from the new to do. I can copy over the new to do and maybe override the ID so that it's the very latest time, right? So this is going to grab whatever texts I might have typed in there, the completed flag, but I'm going to override the ID so it has the very latest value for the time. Okay, so if I refresh, learn Redux, learn node, add, and there it is, learn node or whatever. Okay. Everybody good? That makes sense? So now I can type in, learn node, learn Mongo, right? And I should be able to remove each independently. Okay. All right, let's do something a little more challenging. Let's say I want to, well, actually not that challenging. For instance, we have a completed flag, right? In here, in the reducer, we have a completed flag. And so maybe that could be treated using like a checkbox or a radio button, right? And so let's do that. Let's add here a checkbox next to the text, right? This could be an input field of type checkbox, yep. And the checked could be whether the to-do is completed, right? So there it is. So learn React has been completed. Is that true? I don't remember. Okay, yeah. So it's true, false, false. So yeah. So we have the checkbox, right? Render whether we have completed something. Maybe we can style it a little bit, and maybe put some margins on the right, so they're not flush with one another. So margin and to, right? So just a little bit of space. Well, how about I want to be able to update, right? So if I do a check, right, and I click on it, I like to update the value of this checked, right? So we need an update function in the reducer, right? So let's implement that. Let's do an update to do. It's going to do, there we go. It's going to say, I'm going to iterate over all the to-dos. No, this says, okay, I'm going to iterate over all the to-dos. I'm going to create a new array of to-dos. If the to-do is whatever, if it is the ID of the one you are updating, right, I'm going to take the new to-do that you're passing me. Otherwise, I'm going to keep the old one. And so basically is what we would do, right? We would create a new array of to-dos that either contain the old to-dos, or when we find the one that we're updating, we're going to replace it with a new version of the to-do. Right? So this is perfect. So we've done this already, right? We've done it a couple of times already when we implemented the to-dos a couple of weeks ago, right? So update to-do. So back here, we're going to import that update to-do here, update to-do, so that when we click on the checkbox, right, when there's an update in the checkbox, like when we click on it, right, we can say on change, we're going to dispatch the update to do. We're going to copy the old to do object, which contains the old title, right, the old text, everything else. But we're going to update the completed flag to be whether it's checked or not. Okay. And let's see, that closes here, closes there. That's that one, and I think I need to close it there. All right, so let's see. Okay, there we go. So we can change it and update it, right? And just to make sure that this is working, perhaps we could we can change maybe the color or something, right? And maybe it's bold or not, whether it's done or not. Okay. All right. Now something a little more challenging would be that, say I want to edit this. I want to say that I want to edit the actual text, right, of the to do. Okay. Yeah. So we were discussing being able to edit these to dos. We did a little bit of it. We just showed you an example of being able to update a flag like this, be checked or not. But let's do something a little more challenging. Like for instance, we want to update the text, right? And again, this would be globally available, right, as opposed to editing a local instance. And again, we decided to go this way for the design. We could have entirely done this locally, right, using a state variable, doing a state variable, having the arrays of the to-dos, right, and then editing that array here locally on the screen, and then having a save button that would basically send the entire array, right, that we edited locally, send it over to the producer, and then just copy that payload and just replace the entire to-dos, and then it would be available to the rest of the world. Right? We went the granular way, right, where we are, every single click, we're sending it over for update. Okay, so yeah, so let's keep going that route. So for instance, we want to be able to edit. So first of all, we need to be able to. There are two choices. We could maybe have an edit button that when we click on that edit button, maybe we could do is, just copy this text in this text area. Could do that. Then edit it here in the text area, and then maybe have a button here, like a save button. When we click on that save button, then it would maybe copy it over, right? And then just update the one that we were editing, for instance, right? This would allow you to edit one at a time, right? We can edit either this one, one at a time. We could be able to edit, and then we would save, and then we update the one that we were editing. We could do that. That's one approach. The other approach is maybe we can edit them individually, right? All independently of each other, so that we could have like an edit button. If we click on that edit button, then we get like an input field for each one of them, right? That we can edit independently of each one. So let's go that route. Let's go that route. Okay. Let's see. So here's the text. Here's a text that renders this right here, right? We could have an input field. Maybe it would be a good idea to put this inside of a label. The label here, like that. And then have like an input field here, input, that renders the same text, but in an input field. There it is, see that? Maybe we could make it a little smaller so that it fits. Let's see how we could do this. We could do class name. This would be a form. Actually, we could change the width to be maybe 50. Okay, yeah, so it's a little tinier. And then, or can I make it bigger? That's the same font. All right. Yeah. And then, and whenever we change this, we can say, on change. We could take the event, we would update the new to-do, we would copy over the old to-do, and we would be updating just the text. Perfect. Right, and then we change that. There we go. So here, notice that the checkbox was controlling the completed flag, right? Whereas here, as we're editing the text, we are overriding the text. See that? So this checkbox only controls the completed. We're copying over the old to-do, including the old ID, the old text, right? Anything else would be copied over. Whereas here, we're updating the text only. Right, we're copying the old ID, we're copying the old completed flag, right? But we are overriding the text. So let's see if this works. So learn Redux. And it is indeed being updated, right? And notice that if I go home, notice that indeed is being updated, right? Immediately, because for every single keystroke, we are sending it to the global state. Okay, so perfect. Yeah, that's exactly what we want. Now it's kind of funny that we have both the input field and the label. Ideally, we would want to only show one or the other, depending on whether we are currently editing that particular to-do. Right now, we're editing all of them. Instead, we would want.
어제 한 번 더 돌려놓고 나갔네.
Somebody was speaking. If you could all mute, maybe. Is there a mute, everybody? If you could all mute, please. Okay. Yeah. So maybe we would want like an edit button, right? That would enable us to edit one or the other, right? So in the reducer, we could have maybe an additional flag that would keep track of whether we are editing that particular field, right? So we're saying maybe editing false, right? Maybe just for trying it out, we'll make one of them true. And then in the screen, we could maybe show one or the other, depending on which one we're editing, right? So for instance, we would say, if we are editing, so to do dot editing, oh yeah, excellent. It would be a question mark. We would maybe render the input field, this input field. All right, close the parentheses. Or here we would be rendering just a label. And close the parentheses. And that's it. I think like that. There we go. There we go. See that? Notice that we are here rendering just a text. But here we're rendering the input field because we are presumably editing based on that flag, right? Now what we need to do is toggle that flag, perhaps with an additional button, right? Maybe put a button here right before the X that would allow us to edit the button. So edit button, right? And maybe paint it, say button, warning, and maybe float it to the end, something like that. Something like that. Yeah. And let's put it maybe like that. There's our edit button. Okay. Maybe just for space sakes, we'll use instead of edit, we'll use E. Okay. And so if we click it, so on click, we can say that we're going to update the to-do. There we go, perfect. We're going to dispatch the updates to do with the old to-do, but with the editing flag toggled, so that If it was editing, it becomes not editing. And if it was not editing, it becomes editing. All right, so let's do that. Oops. What do we do? Syntax. Oh, I think we need to close something here. There we go. All right, so if I click on it, notice that, yeah, it toggles. See that? It toggles. So then learn to do, yay, right? And then we stop. So if we go elsewhere, notice that the changes are made available right away. Then also the E should maybe toggle, right? Instead of edit, it should say save. So that E also could be calculated. We could say, question mark, right? And we could say, to do dot editing. So are you editing? If you are, you should say save. If we're not, then it should say edit, right? So that make this a little smaller. Right, so if I edit, notice that it becomes save. See that? When it toggles. Each one individual, and we can edit it. So edit Redux, learn Redux, global state management, save. Right? If I go to home, I can see the changes right away. Make sense? The only other thing is, for instance, here we are changing the checkbox. Right, we're changing the checkbox. We have to click on the checkbox, right? It would be nice if I could use the label as a controller of the checkbox, right? So that I don't have to peck at the small checkbox. So what we could do is that the checkbox, right? This checkbox, we could give it a unique identifier and say ID, right, is equal to the to-do.id as unique identifier, so that the label could be the for, it could be the to-do.id, right? So that now clicking on the text, right, allows you to toggle the checkbox, right? Because now the ID of the checkbox is referenced by the for attribute of the label. Make sense? Right. So there you have it, right? We were able to implement all the CRUD operations of what to do, right? We can create a brand new to do. We can delete to dos, right? We can update to dos. We can retrieve the to dos so that we can render them, right? And we can share it across the entire application, right?